This video covers section 5 of chapter 5, where we get to multiply polynomials. In this section, we're going to talk about the multiplication of a polynomial with a monomial. We're going to multiply two binomials using the FOIL method, and then we will multiply two polynomials together, which of course is a generalization of the first two parts. Okay, so here we have a monomial. It's 6x to the fifth. And we're going to multiply it by a polynomial, or more specifically, a binomial, which is 10x to the 10th plus 12x to the 12th. How will we do this? Well, notice this is really not much different than something that you've seen before. A number or expression a times b plus c, which would be equal to a times b plus a times c using the distributive law. Or if you like numbers, we can go with 2 times the quantity 3 plus 5, which if you use the distributive law would be 2 times 3 plus 2 times 5, which of course would be 16. Okay, well, that's what we're going to do here. We are going to use the distributive property to remove these grouping symbols, just like what we did here and what we did here. And what will we do? Well, we will multiply the 6x to the fifth times the 10x to the 10th, which is what we did here. And we'll multiply the 6x to the fifth times the 12x to the 12th, which is what we did here. And then we simplify. We have 6 times 10, which is 60. X to the fifth times x to the 10th. Well, those using the product rule will give us x to the 15th. 6 times 12 is 72, and then x to the 5th times x to the 12th, again using the product rule, is x to the 17th. So that's it. This type of a problem is really nothing more than an exercise of the distributive property. So let's knock out a couple of examples, and here is our first one. Now here, instead of multiplying it with a nice simple binomial, we're going to be doing multiplication with a trinomial. But once again, we're going to use the distributive property. That will be negative 4x times x squared minus negative 4x times 3x. And then plus negative 4x times 12. All right, so negative 4x times x squared is negative 4x cubed. Negative 4x times negative 3x is negative 12x squared. Taking the minus, that will be plus 12x squared. And then finally, negative 4x plus 12 would be negative or minus 48x. Okay, and there's the first example. Okay, for this problem, once again, we're going to use the distributive property. We have negative 5x times negative 6x squared minus negative 5x times y. Okay, evaluating this, we have negative 5x times negative 6x squared, which would be positive 30, and then x times x squared, that would be x cubed, because once again the exponents add using the product rule. I have minus, and then I will have negative 5 times negative 5x times negative y. I can write that as negative 5xy. That's pretty much all you can do with that. And then subtracting a negative quantity is just like adding the two quantities. So this will be 30x to the cubed plus 5xy. And finally, here at least now we have a positive monomial, which makes life easier, but we are going to use the distributive property again. So that'll be 2y times negative 6xy minus 2y times 3x minus 2y times 2. And I forgot my parenthesis here. Okay, evaluating the first product, I'll have 2 times negative 6, which is negative 12. And then I have x. Then I have y times y. Using the product rule, that would be y squared. Okay, minus 2 times 3 is 6. And x times y is, well, x times y. Minus, I have 2 times 2, which is 4, and then I just have my y, which is y. And there you go. Those are your answers. So once again, the multiplication of a monomial with a polynomial is basically nothing more than an application of the distributive property. What about multiplying two binomials? So let's consider the multiplication of these two binomials, which is in general form. So a number a times x plus a number b, that's our first binomial. We're going to multiply that with the second binomial, which is equal to a number c times x plus some other number d. Okay, well, using the distributive property, we can work this as follows. We can actually just keep this as a term by itself, and we can multiply this term by the ax, that's what I did here, and then I can multiply this term by the b, which is what I did here. So it's kind of like a backwards distributive property because I'm multiplying this term by the a and then this term by the b. And now notice that instead of having two grouping symbols multiplied together, I only have one grouping symbol left. Then I can use the distributive property one more time. I can basically use the distributive property here, and that will give me ax times cx right down there, plus ax times d, which is right here. And then I'll have b times cx, which is right here, plus b times d, which is right here. And now I have no more grouping symbols. But also take a look what I have here. This right here is the product of the first two terms in the binomial. This right here is the product of the outer terms in the binomial. This right here is the product of the inner terms of the binomial. And finally, this right here is the product of the last terms. And once again, if we simplify, we get the exact same thing. Again, the product of the first term, the product of the outer term, the product of the inner terms, and the product of the last terms. And this spells, you guessed it, FOIL. And we call this the FOIL method because it stands for multiplying first, outer, inner, last, and multiplying both things together. And this brings up one important question, and that is, what is the difference between Iron Man and Aluminum Man? Well, it turns out that Iron Man stops bad guys, but Aluminum Man just foils their plans. Ha 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 ha. Okay, moving on. So we have some examples, and here's our first one. Multiplying these two binomials. So let's use our handy dandy FOIL method and see what we get. Okay, multiplying the first two terms together, 2x times 5x. Then we're going to multiply the outer terms. That would be 2x times negative 3. Then the inner terms. That will be negative 4 plus 5x. And then finally, we're going to multiply the last two terms together, negative 4 times negative 3. And then when we simplify, we will have 10x squared. 2 times negative 3 is minus 6x. Minus 20x. And then plus 12. Because negative 4 times negative 3 is positive 12. Now the question is here, are we done? And the answer is no, we are not. Because look, we have like terms here. Okay, so we need to simplify this by combining like terms. And we remember a polynomial is not simplified until you have no more like terms. So here we have 10x squared minus 26x plus 12. And that is the product of those two binomials. So for our next one, we have x plus 1 times x plus 8. This is actually one of the problems I found in your homework. So let's go ahead and do this one as well. Again, multiplying the first two terms and going ahead and simplifying, that will give us x squared. The outer terms, x times 8, well, that's 8x. The inner terms, well, 1 times x is just simply x. And then the last term, 1 times 8, is just 8. And now we need to simplify because, of course, we have like terms in the middle. Combining those, we will have x squared plus 9x, almost forgot the x there, plus 8. And then finally, here we have negative 7x plus 3 times the quantity x minus 1. Again, using our FOIL method, negative 7x times x is negative 7x squared. Negative 7x times negative 1 is positive 7x. 3 times x is, well, 3x. So not much more you can do with that. And then 3 times negative 1 is negative 3. Once again, we need to simplify. by combining the inner terms because they are like terms, and that will give us negative 7x squared plus 10x minus 3. And that would be the answer for example 3. Okay, so we've done multiplication of monomials with binomials. We've talked about the special case of multiplying two binomials. Now we are going to talk about the general case when we were multiplying two polynomials in general. But we're going to look at it at this from this particular perspective, these two problems. However, this problem does scale if you have larger polynomials. And I will show you how it scales. All right, so we have ax plus b times the trinomial cx squared plus dx plus e. And notice we're being general here. We're not going to do any examples. However, I do have this one color-coded red, and of course this one is color-coded black. Okay, well once again, we're going to use the distributive law. We are going to use the distributive law, and I'm going to use this as one term, and I'm going to multiply this by the ax, and then I'm going to multiply this by the bx. So it's kind of like, once again, using the distributive law, but we're going to use it backwards. So I have this term multiplied by ax, there it is, and then this term multiplied by the b, there you go. And once again, I now only have one set of grouping symbols per term. I can now use the distributive law one more time. I can multiply the ax by these three terms and the bx by these three terms. And when I do, we will have ax times cx squared plus ax times dx plus ax times e. And then bx by cx squared plus bx times d plus bx times e. What you'll notice is that I have taken every single term in each term in the first polynomial and multiplied it by every term in the second polynomial. I multiply the ax by each term here, and I multiply the b by each term here. If there was a c or a d, I would do the exact same thing. If there were more terms in this polynomial, then I would multiply the ax by those additional terms. So in this particular case, in this example, which is the one that you'll see most often, there are 6 terms. 1, 2, 3, 4, 5, 6 before you simplify. Once you simplify, it should come down to 4 terms. In general, if your first polynomial had, say, m terms, and your second polynomial has, say, n terms, then the resultant polynomial before you simplify will have m times n terms. In other words, the product of the total number of terms. Okay, so what is this going to look like in terms of examples? Well, here we go. Here's our first example. Here we have 2y times 3x, that binomial, multiplied by the trinomial 7y squared minus 3y plus 2. And once again, I want to multiply the 2y by every single term here. So that's what I'm going to do, and I'm going to do it over here. So I have 2y times 7y squared. 2 times 7 is 14. Y times y squared, using the product rule, that is y cubed. All right, now I have 2 times negative 3y. 2 times negative 3 is negative 6. Y times y is y squared. And then 2y times 2, well, 2 times 2 is 4. And now we just have a y. Now I have to multiply the 3 by each term here. Now I'm going to do this vertically as follows. 3 times 7 is 21, and then I have y squared. Notice I have a y squared here. I'm going to write this below that, plus 21y squared. And then 3 times negative 3 is negative 9. Keep the y, and notice I'm going to put that below the 4y. And then 3 times 2 is 6. I'm going to put that off by itself. And now I'm going to vertically add all the components. So here I have 14y cubed by itself. I'm just going to put that down. Negative 6y plus 21y is going to be positive 15y squared, not y but y squared. 4y minus 9y is negative 5y, and then I'm left with my positive 6. And there we go. This reduces our 6 products into 4 terms. Okay, here's our next problem. This is one that I actually pulled from the homework. Once again, we're going to do it the exact same way. x times x squared, x to the cubed. X times negative x squared. X times negative 2, negative 2x. All right, now we have the negative 5 times x squared, negative 5x squared right below the x squared. Negative 5 times negative x is positive 5x. And then negative 5 times negative 2 is plus 10. And then we can sum all this up, and we will have x cubed minus 6x. And then negative 2 plus 5, negative 2x plus 5x is plus 3x plus 10. And then finally, we have x minus 2 times the quantity x squared plus 2x plus 4. Again, I'm going to take the x squared, multiply it by each of the terms of the trinomial, and that will give me x times x squared, which is x cubed. X times 2x is positive 2x squared. And then x times 4 is positive 4x. All right, now the next term. Here we have a negative 2 times x squared. This will be negative 2x squared. Well, isn't that convenient? And then negative 2x times, negative 2 times positive 2x. That is negative 4x. Once again, convenient. And then negative 2 times positive 4 is negative 8. Maybe not all that convenient, but interesting. So we go ahead and add these, combining like terms. We have no like term associated with the x cubed, so that goes down by itself. These cancel. That should be a 2 there. My apologies. These cancel, and I have negative 8. So all this is equal to x cubed minus 8. But it turns out that 8 is equal to 2 cubed. So this is also equal to x cubed minus 2 cubed. So this right here is a very useful polynomial identity, which you may find yourself using from time to time. Okay, so that is all that I have relative to the lecture portion of this video. So give me a couple of seconds and I will get Hawks up and running. Okay, so here we are in Hawks and it is time to practice. So let's go ahead and start the practice module. Here we are. And here is our first problem. It is the multiplication of a monomial, frankly just negative 3 times the quantity negative x plus 8. So what's that going to look like? Well, so we have negative 3 times the quantity negative x plus 8. Using the distributive law, we will have negative 3 times negative x. And then we will have negative 3 times 8. 3 times 8. All right, well, negative 3 times negative x is positive 3x. And then negative 3 times 8 is negative 24. And there you are. Okay, the next one is something which is just a little more interesting. Here we have the monomial x times the quantity 6x plus 3. Again, using the distributive law, x times 6x is just 6x squared. X times 3 is 3x, and that should be your answer. Now remember the type of the 6x squared. I can do 6x caret squared, right arrow, and then plus 3x. And there you go. Okay, so here is the multiplication of two binomials. And again, we are going to use the FOIL method here. So we have x plus 9, x plus 3. We are going to use FOIL, first, outer, inner, last. And that will give us first x squared, outer 3x, inner plus 9x, last 3 times 9 is 27. Then we're going to simplify. We can simplify these two terms. We can combine those two like terms. That will give us x squared plus 12x plus 27. Okay, let's go ahead and do this one. Here we have 3x minus 2 times the quantity x plus 1. Once again, using FOIL. That will give us 3x times x, which is 3x squared. 3x times 1 is 3x. Minus 2x times x is negative 2x. And then minus 2 times 1 is negative 2. And then we have like terms here that we can combine, and that will give us 3x squared plus, ooh, almost messed that one up, plus x minus 2. And there you go. Okay, and let's look at this problem here. This is actually the last problem in the homework. And here we have the binomial x minus 4 times the trinomial s squared plus 4x plus 16. Now, once again, we are going to take the x and multiply by every single term in the second polynomial. So we have x times x squared, which is x cubed, x times 4x, which is positive 4x, squared, my apologies. X times 16 is positive 16. And notice how I'm doing this vertically. Now I have the negative 4. Negative 4 times x squared is negative 4x squared. Oh, this should be 16x. I apologize. X times 16. Now back to here. Negative 4 times x is negative 4x squared. Oh, that's convenient. Negative 4 times 4x is negative 16x. And negative 4 times 16 is negative 64. And then when we add these, we have x cubed. These cancel, and you're left with negative 64. And there you go. Now the other thing I wanted to show you is that 4 cubed, you guessed it, is equal to 64. So this is equal to x cubed minus 4 cubed. And that is all I have for this particular section. If you have any questions, please feel free to contact me whenever you can. And this is Bob Boyle, signing off.